joint variation. You are welcome. I'm Courage, and this is my Academy of Mathematics, Courage Mathematics Academy on YouTube. If this is your first time of joining us, hit on the subscribe button right now and turn on notification. Today, I'll be teaching you on joint variation. Joint variation. I have taught direct, I have taught inverse variations. So, do well to watch those videos on my channel so that you have a full knowledge, a background of what we are going to be discussing now. So the next video will be on partial variation, and if you want to get notifications whenever that video is uploaded, like I said, click on the subscribe button first and hit on the notification icon so that you get notifications whenever I upload that video. So for now, let's focus on joint variations. Let's go. When we say quantities, a quantity varies jointly as other quantities. This is what it means. If I say, for example, A varies jointly as B and C. This is what it means, B and C. This is times B times C. That is, A varies directly as the product of B and C. I just said two things. I said this is A varies jointly as B and C, and at the same time, A varies directly as the product of what? B and C. They mean the same thing. They mean the same thing. So when a quantity varies jointly as other quantities, you write it as the first quantity varies directly as the product of the two other quantities. Now, listen. This is the formula for the volume of a cylinder. V is equal to what? Pi r squared h. The volume of a cylinder is this is the formula. V is the volume. Pi is the constant, 22/7. This is the radius and this is the height. The volume depends on two quantities. They are the radius and the height. Pi here is just a numerical constant, 22/7. So I can write this equation backward in variation term as V varies jointly as r squared h, or V varies directly as the product of r squared and h. So if I remove this sign, I have my equation back. V is equal to, I will have to introduce a constant which is pi r squared h. So this is the formula. So what I want you to understand now is how to write the variation statement when a quantity varies jointly as other quantities. So let's solve the first question that we have. The first question says f varies jointly as m and the square root of r. When f is 3, r is 9 and m is 3. Write down the log connecting f, r, and m. That's the first question. And find f if r is 16 and m is what? 4. Let's solve this question. The first statement then says f varies jointly as m and the square root of r. So I'll write that as this. F varies jointly as m and the square root of r. So varies as m times the square root of what? R. The square root of what? R. And this is the way it is written. So I'll remove this variation sign, this sign, and turn it to equal to and introduce a constant. So by the time this variation sign disappears, I have f is equal to a constant will be introduced to multiply these two terms, m and what? R. We are given that f is 3 when r is 9 and when m is 3. So when f equal to 3, r is equal to 9 and m is equal to 3, what I will do with this value is to substitute them into this equation and I'll get the value of k. It's simple. F is 3. 3 is equal to k. M is what? 3. That's times 3 times root Arrow is what? 9. So 3 is equal to root 9 is 3. I have k times 3 times what? 3. So 3 is equal to k times 3 times 3 is 9k. 9k. So to make k a sort of formula, I would have to start by 9. So that 3 over 9 is equal to what? 9k over 9. Of course, 9 cancels 9. So 3 into 3 over 9 is simplified to what? 1 over 3. And this is the value of the constant. Now, the first question there says, write down the law connecting F, arrow, and M. The law connecting F, arrow, and M is gotten this way. Substitute for the value of this constant, 1 over 3, into this equation. So that F is now equal to what? 1 over 3, which is now K, which is now 1 over 3, times M times what? Root arrow. So this is the law that connects the variables F, M, and what? Arrow. The next question says, find F if arrow is 16 and M equal to 4. Sorry. So this is A. Question B says, find F if arrow is 16 and M is equal to 4. So when arrow equal to 16 and M is equal to 4, these values now of arrow and M respectively will be substituted into this equation. This law that connects the variables. So F is now equal to what? 1 over 3. M is what? 4 times 4 times root. Arrow is 16. 16. So this is 1 over 3 times 4 times root 16 is what? 4. So this will give me 4 times 4 times 1. That's 16 over 3. And 16 divided by 3 is equal to what? 5.333. It's a recurring decimal. So this is the value of F when arrow is 16 and when M is what? 4. So let's see question 2. Question 2, the last question but not the least. It says a quantity x varies with the square of y. This is the square of y squared, and inversely with the cube root of z. This is the cube root of z. Okay. If x is 6, when y is 2 and z equal to 8, we have to find all this. First of all, let's express this statement mathematically. X varies with the square of y and inversely with the cube root of z. So this is it. X varies with the square of y and inversely as the cube root of z. So it would be wrong if I should write it as inversely as the cube root of z. This is wrong, but rather I have to put a multiplication sign here. So this is what it is. X varies as y squared and inversely as the cube root of z. This is the correct way to write it. So now that you have seen the correct way to write this statement mathematically, let's proceed. It says x will now be equal to what? K, which is a constant, times y squared times 1 over the cube root of what? Z. So x is finally equal to ky squared over what? The cube root of what? Z. We have gotten this first equation. Now let's proceed. It says x is 6 when y is 2 and when z is 8. So when x equal to 6, y equal to 2, and z equal to 8. Let's substitute for these values now into this equation so that we get for the value of the constant. X is 6. So 6 is equal to k, y is 2. So this is 2 squared over cube root of z. Z is what? 8. Let's go. So this is 6 is equal to 2 squared is 4. So k times 4 is 4k. 4k all over. The cube root of 8 is 2. That is a number you multiply by itself 3 times to give you 8. That's 2. This is 2. Now, what will this give us? 6 is equal to 4k divided by 2 is 2k. 2k. And by the time you divide both sides by 2, k will be equal to what? Now 6 over 2, that's 3. So the constant of proportionality, as far as this question is concerned, is 3. So what we have to do now is to substitute for this value of 3 into this equation. And then we would have gotten the formula connecting the variables. So k equal to 3, let's put it into this equation. So x is equal to what? 3y squared over the cube root of what? Z. So this is the formula connecting x, y, z, and z. This is the formula. So we are asked to find x when y is 1 and z equal to 27. So when y equal to 1 and z equal to what? 27, let's substitute these values now into this equation. So x will now be equal to, this is 3, y is 1, that's 1 squared over cube root of 27, that's 27, yeah. But this is 1 squared is 1, times 3 is 3, all over. The cube root of 27 is a number you multiply by itself 3 times to give 27, that's 3. So 3 divided by 3 is what? 1. So it means that x is equal to what? 1. So when y is 1 and z 27, x is what? 1. So the second question says, when x is 5 and y equal to 4, let's find z. So when x equal to 5 and y equal to 4, let's see what the value of z will be. So let's substitute for these values now into this equation. So x is 5, so this is 5, is equal to 3. What's y now 4? That's 4 squared all over the cube root of what? Z. So let's solve for the value of z. So now we're looking for the value of z here. So what we do now is to cross multiply. I have 5 times cube root of z. That's 5 times the cube root of z is equal to what? 3. 4 squared is 16. So 3 times 16 is 48. 48. So now I will divide both sides by 5 so as to free cube root of z at the left hand side. So the cube root of z is equal to 48 over 5. And that will give us what? 9.6. So the cube root of z is equal to what? 9.6. So what to do now to free z is to take the cube of both sides. So the cube root of z, all raised to the power of 3, that's what it means to take the cube of both sides, is equal to 9.6 raised to the power of 3. Whatever you do to the left hand side of an equation, do same to the right hand side, and vice versa. So this cube will take away the cube root, z is left. I have 9.6 raised to the power of what? 3. That is what? 84.736. So this is the value of z, and this can be simplified, presented to 884.74 to 2 decimal places, to 2 decimal places. So this is the value of z when x is 5 and when y is what? 4. So this is in joint variation. So I actually taught you how to solve questions under joint variation, practicing with 2 questions. This is all I have for you today. Don't forget to subscribe, and I hope you like this video lesson. If this is your first time joining us, like I said earlier, hit on the subscribe button and turn on notification so that you get updated whenever I upload good content like this. I'll see you some other time.